Las Vegas is the largest city in the world established after 1900. We've had massive growth, so the Springs Preserve became a catalyst for our community to reflect on where we came from, but also talk about where we want to go into the future.
The Missouri Department of Natural Resources, Lewis and Clark building, became the first LEED Platinum state office building on a standard state office building budget in America.
The Botanic Garden invites people into the building to see how research is done, how science is progressing. It's big science on display.
When you look at the fact that well over 90% of the buildings that will be in New York City in 2030 already exist, it's not enough just to build new efficiently.
The buildings are teachers themselves. How we take care of each other and this place has become a major emphasis in weaving our curriculum together.
When we started the design of this building, we decided to use a totally different design process than we've used in the past. I'm convinced the only way you can design a super high performance building is by following this process of integrative design.
Buildings are huge users of energy, materials, water. Where we put them determines how much we need to travel around. And of course, buildings are also a slow turnover capital stock. So once you build a building the wrong way, it will continue to gobble resources for decades.
Traditionally, buildings have been created by an architect with an idea, who then gives that three-dimensional idea to a mechanical engineer, a structural engineer, a landscape architect, etc. And they say, here's the building now, heat it, cool it, put a structure around it, etc.
Integrated design requires that we start early with getting more input into the process. So a lot of times we'll be bringing people in that you would normally not be talking to until quite a bit later on in the process.
Generally, we conventionally design how a building looks and then figure out how to make it work, mechanically, electrically, sustainably, etc. This process sort of turns that inside out.
Integrative design means designing the building as a whole system and optimizing it for multiple benefits, rather than optimizing components of the building or subsystems in the building for single benefits.
I can summarize integrative design in 4 words, and they all start with E. It's everyone engaging everything early. It comes down to an oscillating rhythm of research and analysis by individuals on the team. They then come together for an all-hands team workshop to compare and look for interactions from that analysis, go off again, do more research and analysis, gather that, come back again to a workshop.
What are the implications of that type?
Always looking for key interrelationships between systems and systems components.
But I think if
integration doesn't happen instantaneously. We have to introduce issues and iterate them, but we have to allow time to consider those ideas and time to connect the dots of one idea with another idea.
Phipps opened in 1893. It was originally a gift to the city of Pittsburgh from Henry Phipps, who was one of Andrew Carnegie's partners in the steel business. This new building is our education, research, administrative offices. We're calling it the Center for Sustainable Landscapes. We actually put in an RFP that we were going to require the design team to follow facilitated integrated design. They had to agree up front that they were going to follow this process or we wouldn't accept their proposal.
get out the bottom.
The real first team activity was a one-day goal-setting workshop.
Everybody gets 40 votes.
To identify those goals and prioritize them. Therefore, it's the consensus of everybody on the team, and it's very clear from the outset that we are all aligned around those initial goals.
So I think the difference is architects tend to think that they're in control of everything. And I think in the integrative design process, you have to let go of some of that control and allow things to emerge that you hadn't necessarily planned on. And that's a hard one to grapple with sometimes.
By the end of the day, everybody was like off their chairs and pens in hand and scribbling on paper and making drawings and talking about this. Hey, I'm just thinking about doing this. How will this affect your system? What do you think about this? I mean, those kinds of interactions just took place all day long. It was really incredible.
Our approach with FIPS was to minimize the overall energy consumption of the building first.
The goal we have at FIPS is to achieve a daylight autonomy of 80%. What that means is that 80% of the daylit hours, the lights should be able to be completely turned off.
If I have a really good passive high-performance envelope with really good glazing and passive controls of the sun, I can actually reduce the capacity and the requirements of my HVAC system, which means that my wires are smaller, my ducts are smaller, my pipes are smaller, my pumps are smaller, my fans are smaller. So I'm saving money on that side and reinvesting it or shifting it into my envelope.
Other options, it could be a double hung.
And so if the entire team doesn't participate in that process and understanding that one impacts the other, then you will not get the benefit of that integrated design.
I think this approach does require a lot more time up front. And you know, it was interesting. By the time we got to the construction document phase, we just flew right through that because we'd already figured out all the problems and solutions back in schematic and design development.
We'd use computer simulation of various elements of the building, the energy performance, the daylight performance, thermal comfort. It really does help refine some of our designs and inform us.
Schematic design is really when you want to do most of your load reduction analysis. So you do a computer simulation of the building's performance, trying to guide the design decision very early on. Then you start doing more serious iterative modeling runs. And the goal there is to really try and optimize the performance of the building so that you've driven the loads in that building, the heating and cooling loads, as low as you possibly can.
We still have to do fundamentally great design. We have to figure out the innovations, and then the computer simulation will help us refine it. But it does give us the ability to try things before the building is built and save us a lot of money.
So as we're changing the way we approach energy efficiency for the building, it also changes the economics. And it's really the balance of those two, obviously, that a commercial owner is going to want, how they can get the most return while reducing their costs.
One of the first nationally visible examples of an integrated design process was the Missouri Department of Natural Resources headquarters building.
Integrated design for us refers to a basic notion that no one knows as much as everyone. And so what that means is we try to get as many of the right people at the table so that each voice can be heard.
When you look at this facility and the way it was organized, what you discover is that every major form, place, shape, and material selection was a direct result of this integrated conversation.
So we're trying to find this optimization where we do have great architecture, but also high performance, meaning low energy, and great comfort. Visual comfort, thermal comfort, acoustic comfort, and we can get all of that if we work together early in the design.
Putting all the core facilities in the center allowed for displacement air, totally daylit space. It changed the basic concept of the building as a direct result of that intersection of disciplines. Daylight, energy, pedestrian comfort, all that ultimately defined the end result.
And we came up with a system of light shelves, sunshades, and structural support that's all one system. One system to serve many uses. That's when we find the cost-effective, high-performance answer.
We were a team committed to changing the lifestyle and the quality of life for all the employees at DNR. They love what they have, they're healthier because of it, and it requires less energy and so on.
2 years after the building had been occupied, I talked to the person who was running the building, and he said, you know, this building has been working wonderfully. We have in 1 month something like 2 or 3 hot, cold calls. That is phenomenally low. For a building that size, the number typically would be 20 or 30. At the beginning of the design, we want to be intimately involved, where we're talking to the architects when they're making the key decisions that affect energy use, the building orientation, the size of the windows, whether or not there's overhangs, the whole building envelope. That stuff is the cheapest thing that you can do to make the building more energy efficient and perform better.
Integrative design is not simply going from here to there. There are a lot of eddies and currents going back and forth because you have to keep looping back from what you learned at each stage of the design to improve what you already did.
I liken the role of a project manager on a highly integrated project with a choreographer. You're essentially deciding when there's a big ballroom dance and everybody has to be there working together. There are times when you want just a soloist to really focus on their piece of the work. Sometimes it's 2 systems, 2 people working closely together to make one piece of the building work really well. And it's figuring out when to have those different dances occur as you move through the design process.
The Chicago Botanic Garden opened in 1972. 385 acres, 9 islands, 60 acres of water, 750,000 visitors a year, $28 million operating budget.
The project was already quite far along when we got involved, so we convened several meetings of the whole design team.
We brought on Rocky Mountain Institute in the construction document phase of the job, which I don't recommend people do.
Bringing people up to speed was really important because they had figured that, oh, we've missed all of our opportunities, and that wasn't at all the case.
The biggest energy consumption is the mechanical systems, and so we really had to sort of stop, reevaluate all the systems. So it was exciting, but also stressful and frustrating because it started late.
There were a number of items that they questioned. Why would you put a smaller chiller in the building and use that money for more energy efficient glass? So we're trading costs from one building system to another building system.
One of the issues was how much glass do you really need and where do you need it? I think the whole clear story piece in that larger entry atrium space was very interesting. When you look now at the way that both electric light and daylight are delivered to that volume, it's pretty successful.
The design team was really critical in this, in keeping an open mind and open to suggestions on their existing design that they did have a lot vested into, but they were all still very much interested in continuing to make improvements on it.
We're using a steel trellis with the photovoltaic panels as a shading device above those windows. There's a clear story glass window and glass doors, so the light penetrates into the open office area. The ceiling slopes, so the enclosed offices, light comes in, literally bounces into the open offices. That proved to be a pretty effective technique.
The Chicago Botanic Garden staff were really excited about thinking in an integrative fashion and reevaluating some of the opportunities that they may have already overlooked.
The process we went through was such a useful exercise that I could see we should have done it back at schematic design.
We came in with a healthy dose of skepticism about it, and having come to the end of it, we realized, wow, there's a lot to think about here.
We began our involvement with the building in 1961 when my grandfather Lawrence Ween, my father Peter Malkin, and Harry Helmsley bought the building. So our experience started a year before I was born. It's an incredible burden and joy to work with.
We're in the midst of a $500 million upgrade to the property that includes renovating all common areas, mechanical and electrical system upgrades, so virtually complete building-wide upgrade program.
We have to prove it's good economics.
The process actually started in May 2007 at the Clinton C40 Cities launch.
Early on, we had a large brainstorming session in which we came up with over 70 potential energy efficiency measures for the project.
In this case, it was an iterative approach. We would get some information together, we would share it amongst ourselves, come back, we would have debates. Usually you get, hey, this has worked for me in some other places. You zero in on those things. But we actually challenged ourselves to look at other things that we don't normally do.
We tested close to 70 ECMs, energy conservation measures, by modeling them against the energy consumption profile. And we only chose 8. Together, those 8 energy conservation measures, deployed in the building and in tenant spaces as we refit the building for new tenants, made the difference. 38.4% savings.
Historically, we've taken a look at windows and we say, oh, they have a 20-year payback. There's no way it's going to work.
When you look at the size of the building and how many windows there are, it's a huge percent of the facade. I think everybody said, what? And then after we all looked at it, one by one, we all became believers, and now we're going to do it.
We're actually taking down 6,500 windows, refurbishing them, making them more energy efficient.
By changing the building envelope insulation both through the windows and against the walls themselves, it lowers both the heat and cold loads on the building.
The way we as engineers like to look at it is what we call interactive effects. When we think about, well, the windows are going to do some good, well, yeah, they'll save energy, but more importantly, they'll make our system smaller. Our heating system is smaller, our cooling system is smaller. That optimization is much different than just what's the energy savings from a better window.
Integrated design was really important because it forced us to look not only at energy savings, but also at capital cost savings. If we had just looked at projects in isolation, we would not have come to that conclusion.
I'll give you a sense of the impact. As part of our program, we thought we're going to have to retrofit and upgrade the cooling of the building. We're going to have to add capacity. We actually have overcapacity in our cooling because we've reduced the heat load and we're managing the heat load better. So there's massive innovation here by looking at an integrated approach.
In a multi-tenant building, you have to think about the people who are going to live in the building. So one of the really exciting parts of the Empire State Building is the fact that the owner has decided to do some pre-builts that demonstrate that you can marry energy efficiency with ambiance. It's a way to very concretely convince tenants that they can reduce their carbon footprint, reduce their energy, water, heating needs, and at the same time have a very unique and interesting space.
We're going to be delivering the exact same work environment. In fact, perhaps a healthier, better work environment for far less energy consumption. And particularly in doing the project as part of a total comprehensive upgrade to the building at any rate, 3-year payback.
What we found is that high-performance buildings aren't about adding a green covering at the tail end. That's always expensive, and that's what gives building owners and other folks in the building community the impression that green buildings are expensive.
What we try to do is look at all of these systems, how they fit together, and then see what elements are redundant and what can be eliminated.
We may spend more on insulation and windows, be able to make a smaller heating system, and then operate it at much lower costs over time. So that's the concept we call tunneling through the cost barrier.
We're so conditioned to thinking that very efficient must cost more, but through integrative design, you can tunnel through the cost barrier. At first, the cost goes up as you save more and more energy, and it goes up more and more steeply. That's called diminishing returns. But if you keep going, you often get to the point where you can eliminate mechanicals, for example, and then the cost comes down more than you paid to get there. And why should you get there the long way around when you can tunnel through the cost barrier directly to that destination?
The Willow School is a school for children in kindergarten through 8th grade. And it is a place that truly captures the essence of teaching and learning.
Honor. Let's see what honor is good at.
Our first building, which we built and completed in 2003, was the first LEED Gold independent school building in the country. And it was a real labor of love to build because in those days, no one was really talking about this, and the resources that you have today are just exponentially more available. The way we learned back in 2000, and we were lucky enough to have some very, very good mentors, was to do it in a way that may cost you a few extra dollars up front in the planning process, but saves a tremendous amount of money as you build the building. And that's the way we developed the whole campus.
But let's discuss the principles.
They were already in design development.
You could have a whole office.
Now, this is what I find fascinating, is that to Mark's credit, he said, stop the presses, we're going to revisit everything.
That would probably not be the smartest way to build a building.
So it was an education process that we took the time to do.
It's not only just a modeling issue, Stephen, it's also a comfort issue.
You're talking about a philosophical change in the way we look at things.
That's okay.
Rewind to 2002. We walked into our township with this concept of a green building and started talking to them about some of these concepts. That helps mitigate and the pushback that we got. Oh, you can't do this. This can't be done. The town will never pass this. What kind of thermal loss are you talking about? Heat going out?
Yeah, versus your roof insulation.
And now, fast forward, and what we get now is tell us more instead of, go away.
One of the big drivers at Willow was the fact that they wanted to educate people on environmental, human health, sustainability issues, and frankly, what better way to do it than to actually walk your talk and do it in the development of your own building.
The buildings are teachers themselves. High academic scores are important, but knowing how to relate to people and to relate to your environment, how we take care of each other and this place has become a major emphasis in weaving our curriculum together.
In 2007, we completed our second building, which we built to LEED Platinum standards. The great thing about that building was we were able to build that building for $295 a square foot. We feel that that's moving into the realm of being able to build in the public school sector. So I think the education of everybody, from myself to our teachers, to our administrative staff, to the students, to our community, it's affected everybody. It truly has.
The entire site of the Springs Preserve is 180 acres. We developed about 30 acres in landscape around the buildings for the public use.
For the Springs Preserve to be a sustainable place, it wasn't so much that the buildings were platinum, LEED Platinum, which they are, 7 of them are. For us, sustainability includes all of that, but also has things about the people, the culture, the attitude, operations.
And that's the question.
Everybody was at the table talking at the beginning to look at a whole thing, not the traditional, there's a design, then there's a mechanical system, then there's a structural system. We had a team that was dealing with ecology, restoration, interpretation, exhibits. They were all there together.
It was really gratifying to bring all these people around the table and brainstorm sustainable principles where mechanical designers started with, what do we design a building with no mechanical systems? And it created a really dynamic synergy to philosophically push this into a building that performed at a high level.
There was a 22-acre flood detention basin that in the master planning process, everybody said, gee, why not use this as a potential for demonstration of what a native spring and wetlands would look like? Let's make it a demonstration facility.
The parking lots are covered with, I believe it's 2,200 solar panels that develop about 409 kilowatts of electricity. And that's about 2/3 of what it takes to run these facilities.
The Desert Living Center shows these pieces and parts all working together as an integrated system where landscape is fused with building architecture, which is fused with mechanical systems, and then daylighting.
In the desert, there's a lot of light available all the time. There's a lot of heat available all the time. So really, the shading and the building form really was informed by that specific location, climate, and orientation. So it was aggressively, passively designed. That led to the need for a daylit building that really didn't have much electric lighting load.
We've cut our water consumption by about 65%. It still is a botanical garden, so we do use some water, but we also reclaim all of our wastewater. And then we run that water back into the buildings to flush toilets. So we have no sewage that leaves this site. There's 5 buildings in the Desert Living Center. All of them use cool towers. One of them has no mechanical systems at all. These are working laboratories where we can see which ones perform better at what times of the year and teach our greater community and other architects the abilities of what can be done with sustainable design now. The integrated design process was taken to another level on this project for us when we brought all these different components, civil engineers, mechanical engineers, electrical lighting engineers, daylighting experts. And I cannot imagine doing a building anymore without doing that.
One of my favorite Einstein quotes is the definition of insanity, right? Is doing the same thing over and over, but expecting different results. So if we expect buildings to perform significantly better, we need to change the process by which you put them together.
In a collaborative design process, you need to and you want to understand each other's disciplines.
One is we know that we need breakout space for this one.
Collaborative design is a lot more fun.
The integrative process asks us to understand that maybe rather than either or, we can achieve both and. That's when you know you're really on an integrative path.
When the whole team works on the whole building as an integrative design problem, you pay less and you get much better results. Everything gets better. There is no compromise, no trade-off.